Hi, this is a video about page 6 in your packet about drawing force diagrams. You should have tried all of these questions already before watching this video. If you haven't tried all the questions and at least tried to figure them out, spend at least 10 minutes on that, you should not be watching this video. Stop watching this video and come back to it. So we're going to start with question 7 actually. If you didn't get question 6, that's all right. But let's focus on question 7. Question 7 is important because we're looking at what the object of interest is. It is no longer the ball. This is a familiar situation, but we've got the ruler as the object of interest rather than the ball. The ball is still important, and it is still interacting with the ruler, but the ball is not the object of interest. The other object that's important that's interacting with the ruler is the person. So I'm going to say that that interaction is important too. Now I need to think about which direction these objects are pushing or pulling on that ruler. And I'm going to start with the ball. And I'm going to say, okay, it looks like the ruler is bending kind of this way. Like it would be straight, except for it's being pushed to the right by the ball. So I'm going to make a direction, an arrow to the right. I'm going to call this arrow F ball on ruler. Again, I know that the ruler has to be the second object in the name because the object of interest is the ruler. The ball is pushing on the ruler. I also know that the person is pushing on the ruler, and the direction isn't totally obvious here. I'm going to say that the person is pushing this way, but that might not be exactly right. I'm just going to assume that I know that the person is pushing this way. I know that the person isn't pulling the ruler that way, but they may be pushing a little bit down or they may be pulling it up. I don't know exactly. The important thing is I have a second arrow here, and I call this arrow F person on ruler. If the direction of this arrow wasn't exactly the same as I have here, that's all right. Last thing I need to do is check these multiple representations. I can see I have 2 interactions with the ruler, and I have 2 arrows, so that checks out. That's perfect. Moving on to question 8. This is kind of similar, except the person is now the object of interest, and I can read the description and say, a person kicks a bowling ball and hurts their foot. You may have experienced this before. If you walk up to a rock or something, you kick it, you end up with a hurt foot. This question will help us understand why your foot ends up hurting. So we're going to start with a system diagram. We'll say this person is the object of interest. We put a dotted line around that person. And again, we're still ignoring the up-down interactions. Yes, the earth is pulling down on the person. They're probably standing on the ground. We're ignoring those for now. They're going to become very important very soon. But we're only focusing on the interaction between the person and the ball. The person and the ball are definitely interacting because this person kicked the ball. But we don't care the direction that the person pushes the ball, which I would say is this direction. We would know that ball would probably speed up this way because this person pushed the ball this way. We care about which direction is the ball pushing the person. That is, which direction does the ball interact with the person? And I would say that the ball is actually pushing the person this way. That is, the person kicks the ball, and the ball kind of is there to stop the foot. So if this was a ruler instead of a person's foot, it would be this situation. Or it would be that situation that we saw on the previous page where we know that the ball is actually pushing that ruler. So we knew this has got to be F ball on ruler to the right. That's why the ruler is bending. I'm going to assume the same thing here and say F ball on person is pointing to the right. Again, we're trying to use this force diagram to explain why this person hurt their foot. Ouch. The reason why that person hurt their foot is because the ball kind of kicked them. Like that is like they kicked the ball and there was an interaction in the opposite direction of the ball kicking them. We're going to get back to this a little bit later. It's a tricky idea that when you have an interaction between two objects, they both affect each other. This ball might speed up and this person might end up with a broken foot. Those are two effects of that interaction between the objects. If this is confusing, that's all right. We'll get to it later. It should be confusing if you're really, really thinking about it, but this works. We've got one interaction with the person and one arrow on the force diagram. Last thing, for these two, we want to consider up, down, and left, right forces. I'm going to leave you to figure this one out on your own. I encourage you to use this hint. Look at the example on page 3, and we're going to move on to question 10. We're back to using the ball as the object of interest, so I'm going to say the word ball. I'm going to say this is our object of interest, and I'm going to identify all the objects interacting with the ball. I know I have a ruler interacting with the ball. There's the wall interacting with the ball. But this time we have to consider the floor as well, and also the entire planet Earth that's interacting with all of these things. So this becomes tricky. We said it would get complicated quickly. We have 1, 2, 3, 4 interactions with the ball. That means we're going to need 1, 2, 3, 4 arrows on this ball. So we need to figure out which direction everything's pulling and pushing. We'll start with the left-right things that we've seen before. The ruler is pushing to the right, so I'm going to make an arrow to the right and call that F ruler on ball. The wall is pushing to the left, F wall on ball. You might say like, wait, walls don't push on stuff, but we're not using the definition of a push as our definition of force. We're saying, is there an interaction between the wall and the ball? Yes, there is. If there is, then there's got to be a direction to that interaction. So we're not asking like, is the wall like pushing this ball actively, like I'm pushing this pencil? We're asking, is there an interaction between these two things? That is our definition of force. I've got 2 arrows here, but I know I need 4. So I can tell, okay, I've already done the wall interaction. I've already done the ruler interaction. I'm left with the earth and the floor. The earth always pulls down on stuff. So F earth on ball is pulling down, and the floor is pushing up. So F floor on ball is pushing up. Notice all 4 of these end with the word on ball. The object of interest is still the ball here, so we need those names to end with that word. I count out my interactions 1, 2, 3, 4. I count out my arrows 1, 2, 3, 4, and we're good.